Draft physics video. Just decided to do it. So I'll read some comments. Still, the Tony guy is being impolite, but whatever. I just don't get people. I mean, they badger me on points that I've made it so clear, and they just keep badgering me as if there's some lack of clarity. And it's just, no, it's clear. Anyway, I was thinking a little bit about the interferometer through the LIGO experiment, and interferometers in general, and the little subtle problems. This whole idea of putting things in phase and measuring things out of phase. And as I pointed out, you could probably just use two regular lasers if we could control the phase of those lasers. So if you made a lasers that were very reliably, their phase was very reliable, and which they sort of can do, but cheap lasers aren't going to do that. There's still some tricks, to this phase equation that make it a little, subtle complications. So anyway, it's a simple enough experiment to draw it. So the idea is you send light through. Half the light goes through the glass, the other half reflects. Now, as I've pointed out, the half that goes through is really going through a diffraction gradient, which means there's holes, random and evenly spaced, to the reflective space. So it's a 50-50 chance you go through one of the holes, or you hit the non-hole, and you bounce off. And what that basically creates is a diffraction gradient that ends up, in light experiments anyway, spreading light in a Newton ring kind of pattern if you have the holes randomized. So it's like a two-slit experiment without, but it's not. You don't need two slits. You can make it in three. You can make it more dimensional. And so it ends up being just rings of light that you'll end up creating. Like so. Anyway, and and that's basically a divergence. That basically the light is diverging because of that spreading. To create the ring, it's spreading the light more than if it wasn't diverged. So if you didn't go through the gradient, the light wouldn't diverge as much. So you kind of have to understand that the light goes through, and then the light that reflects goes down one arm, isn't diverged, and the light that goes through starts diverging as it goes towards the mirror. And there's already a pattern now in it of Newton's rings in terms of its intensity when it hits the mirror and bounces back. And as it bounces back from the mirror, theoretically, it's going to still be diverging even more. So you have two paths of divergence. And this other path, it's not diverging. It's still a relatively small pinhole of light when it gets to the mirror. And this one passes through now and just diverges this short distance, while the other beam has been diverging quite a bit and will be coming back much wider. And so what they're really comparing is the smallest part of the one Newton's ring pattern with another Newton's ring pattern that's at a much different size or scale. And you can certainly still superimpose those on each other and get an on-off kind of result. But I'm just saying this has to be happening by their own physics. The other problem is this mirror, because theoretically the light that goes through, well, I should do it all the way at the ends. The light that goes through here, let's say, and then goes back to the mirror, bounces back, comes back here and reflects. And the light that hits the mirror here, goes through, bounces back, and then reflects. These are reflecting off of different positions of the mirror. So although the going through distance for this line and this line are exactly the same, to get to the mirror, these lines are exactly the same distance. these lines aren't going to be the same distance. So the one side of the ring, this side, is going to be at a different phase than the other side. You're automatically going to have a change in the phase of the light on the ring on one side than the other side. They're going to be in opposite, or could be. Just depends on how wide this beam is going in. But clearly the beam's a lot wider, the size of the laser beam's a lot wider than the distance between photons. The wavelength of the light is much smaller than the thickness of this beam. This beam is probably inches across. So you use a very powerful laser. But let's say it's only a centimeter. A centimeter is still a huge amount of distance. This would be, this angle would be this distance would be a centimeter of distance, theoretically, which is, huge by comparison to the nanometer light wavelength. So in theory, you could end up with a lot of these rings being out of phase. And the trick is this one, the difference in the timing. So this is for light that hits this spot. So in this one, when it goes back and forth, when this one reflects and goes this way and then comes back and then goes through, this one went the longer distance also. So at least in that sense the two will be consistent. I have to think about, no, this one goes the longer distance. So this one's going to actually be the shorter distance. Let's see, but this is the longer distance this way. I have to think. Yeah, I should have thought about it before I started. So anyway, so this distance is going to be longer than this distance. Okay, so that's for sure. This one's longer than this one going this way for the reflection. And that's the only reflection there is. The rest, yeah, the going through part doesn't change it any, so it's only the reflection part. So this one is clearly going to be the one that travels the shorter distance, and this one's going to travel the longer distance. Can't be shorter because it's longer this way. I still have to think about that. It's longer this way, and that's the only one that counts. Okay, so yes, so these two would be, so at least they would be the same. So both beams are going to have this wavelength on this side is going to be fundamentally different than the wavelength on the other side, which is sort of interesting. I mean, it still makes the experiment work, but it would only, the intensity of the light would have to be different on those two sides, because it would have to be just circumstantial luck that this would be a multiple of the wavelength of the light, that the distance of the beam's width would be a multiple of the length of the light. So anyway, what they actually see, which we don't get to see, what actually goes into their computer to be analyzed, whatever light they're looking at, we don't get to see that. We haven't seen it anyway. They don't show that. The blinking of the light. But I think clearly there have to be some consequence to this difference in the path length created by the mere fact that you're reflecting off of a different length from the receiver. I mean, there's no way to avoid the fact that this distance is different. Alright. So anyway, just throw that in for free. Anyway, so 2 comments, which may require some drawing. We'll see how it goes. So Bob Hicks says, Gary, thank you for the clarification on force and matter bits and the acquisition or exchange of force. I clearly understand what you're saying. If I'm not mistaken, your explanation also describes what happens in Newton's cradle. Well, it certainly describes it in the sense that it relies on this idea that some exchanges are very fast, force exchanges, and some force exchanges are very slow. So that's, as Hathaway pointed out, in gravitational acceleration, in the first second of your acceleration, you only go 5 meters instead of 10 meters because of the time it takes for the acceleration to get you moving, time it takes for the process of acceleration to move through you, so to speak. There's transition time, where if I bump something with a hammer in space, I just hit it with a hammer, it automatically accelerates to the new speed. It's very quick. And that's like the kinetic balls. So that's Newton's cradle, is the kinetic, steel ball thing. And that's like, it's not instantaneous, but that's as fast as you get in terms of a transfer of force. The force is essentially transferred at the speed of light. And that's a whole interesting phenomenon that I haven't given a whole lot of thought to, but just the fact that how does force how is it so effective at doing that? Say if I had 6 of those steel balls in the strings, and I pull 3 of them back and I pull 3 of them back. Alright, I leave 3 and I pull 3 up, and I let the 3 fall. The new 3 will stay and the old 3 will do the swinging, and then the same thing will happen, and they'll just transfer that force through them, and quite efficiently. And it's like, how do they know, not to partially move or do something? How does the steel ball, when it hits the steel ball, know that's how much total force it has? Because you'd almost seem to think, how does it know how deep the force goes? And so that's an interesting question, because you'd think from intuition that it's going to just take some time for that force to make itself known to the thing it's hitting, and before it makes it known, it's going to move it a little bit. And I suppose it does move it a tiny bit, but it's not much. So that's how quickly the force is transferred. That's how willing the atoms are of the thing moving to give away their force. It's easy to grab out of them. It moves out of them freely and fast under the right circumstances. And but that's almost like electricity. It's almost like as if it was just electricity moving through a conductor. It's moving that kind of way. So anyway, it's sort of an interesting subject I'll have to think more about. But that's it. Also just brings up the idea that there's a difference in time, between different objects, and how quickly, their atomic structure really. And that's sort of like their steel balls or glass, or it's made out of something very rigid and unyielding. Because as soon as there's a yield, then there's going to be, that's when force is slowly pushed on something. When you push, and you just deform it, that's a different kind of transfer. How to say it better? Well, anyway, but the idea is just that the important thing to recognize is, so these different arrangements of matter will hold force in a way that, like, the atoms aren't going to move, but the force can go straight through them easily. So there's force in between the electrons and protons, and it's that force that's just being transferred. But the idea of understanding that one little thing goes in, and it has to basically spread its force over everything that's not going as fast as it. So every piece in here that's going the same way as this thing's going, obviously it can't catch that, because that piece has already gone through the matter, and it will make an exchange with the field, in the sense that the field energy will give it a new piece going this way, and it will release this piece going that way, and there'll be an exchange. But anyway, well, that's sort of important. I shouldn't just fluff over that, because that has to do with this constant. You always have to remember that no matter what circumstances something's in, there's all this field, this thick fog of energy that's always around everything. And so that's the real part that makes it all unintuitive to us, is we don't see it, we don't feel it, we don't realize it but there's this tremendous amount of, I mean, at the end of the universe is thick with these arrows. I mean, thick, 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 thick. I don't know, I don't know how to describe it, but it's really thick. And that's the dominant thing that's always affecting everything. And there's the little effect is the subtle imbalances you can create inside of something. So you have to kind of always understand that everything has to function in that consistent field of pressure that's constantly pushing the electrons and holding them together, and holding the protons together. Everything's being held together by this pressure pushing. So anyway, but the idea is a force comes in and it has to basically correct for every bit of energy that's going the wrong way inside of something. It has to move it forward. So you have to think about it. You have an arrow going this way. You have a force going this way. The idea is you have to convert this arrow into being here. You have to move it forward. And you have to get it to keep going forward, even though it's registered as going this way. So this is almost part of the time dilation argument, in the sense that it takes time for this one piece of force to correct this arrow for a tiny moment, make it go the right way. Alright, and then it has to correct some other arrow or some other arrow, but they all have to be corrected constantly to keep this motion happening. This motion can't keep happening unless the force has to be in there, and it has to be constantly correcting for that. It has to keep moving those arrows that aren't going the right way, the force that is inside of something going the wrong way, to go the right way. And that's why something can't travel the speed of light, material things. Because material things have these three dimensions. They have force in all three dimensions. And if you move all of my force that's going in all the other dimensions into stuff going one way, then that's all I am, is stuff going one way. I'm not a school of fish anymore. I'm just individual fish all going one way. I'm a bunch of force, not matter. So in a sense, you can't make matter go the speed of light beyond the fact that you can make it go the speed of light, but it's not matter anymore, it's force. You've turned it into light. You've turned it into a force by making it, by purifying it, by essentially removing the other dimensions. And so now it only has force in one dimension, just like those little bits, the photons. They only have force in one dimension. Three-dimensional things can't move the speed of light in one dimension because they have stuff going the wrong way. And that stuff has to be constantly moved this way. And that takes time. I don't know if that was helpful or not, but close enough. Alright, so now the Tony guy. This is my last chance with you, buddy. Okay, I'm just not going to put up with any more of this crap. So if this is the kind of crap you want to waste your time with, then fine, go somewhere else, because I'll just block you. Because I'm just not going to argue the same crap over and over again. I explicitly even said after those relativity videos, okay, it's done. Okay, they can't be argued because nobody has the evidence. Nobody can move matter anywhere close. I mean, the fastest thing we have going is the Pluto probe, and that didn't even hit 30,000 miles an hour or something. So we can't get anywhere close to the speeds necessary to do these experiments. So there's just no point. So he says, are you saying you could never shoot a laser out a hole if the ship is moving less than the speed of light, of course? Okay, some fast speed. I didn't say you could. I'm saying by their theory, you can't aim it. Aiming is impossible. Because no matter where you aim, they're going to say, okay, that the photons come out some other way. So you can't, there's no, and if you deliberately aim, then you've already broken the rules in the sense that you've created the longer line. If I aim to the future, to get it to go through the hole, then there couldn't be any perceptual nonsense about how much distance I went. I have to go longer distance to go to the future. I mean, going this way is short, going this way is long. So the timing wouldn't be the same. So if I get through the hole, I didn't get through the hole in the right amount of time. So I'm saying this stupid relativity thing, they've had 100 years to play with it and create all catches. So they have catches for all this stuff. That's all I'm saying. I believe photons. Look, I said it explicitly in the fucking video and you're still not getting it. Alright? Photons can't be affected by the thing producing them. The motion of the thing producing them has nothing to do with how the photons travel. Nothing. Zero. Alright? So I've already stated that I bet if you actually do the experiment, the laser beam comes out perfectly straight and would miss the hole you aimed at because the hole is moving, and it's moving really fast, and the light can't get there in time to get to the hole. It would have to move instantaneously to get to a hole perpendicular from the laser. So of course you have to aim ahead. But the point of the relativity experiment was, can you get light out the hole? And the point was, you can't unless you change the aim of the laser. And so that would give you an indication of how fast you were going. The more you had to move the laser would be like a speedometer. It would tell you how fast you're going. That was my argument. But their argument is when it's pointed this way, the light comes out this way. You know, it's their catches, not mine. Damn. Because I remember reading about a Canadian sniper who killed an Islamic State fighter from a distance of 3,500 meters with a rifle. Now, I hate to explain it to you. Fuck you. Again, we're not talking about, it's even more amazing when people hit running targets or something. So who cares? Yes, obviously you have to. That's not. You're just not even getting the argument here, or what they're arguing, and you're not listening when I say explicitly to you that yes, I believe when a laser is pointed this way, the light comes out straight. That's what I believe happens. It's not what they believe happens. Anyway, I hate to explain it to you, but that wouldn't have been possible if he hadn't aimed aimed directly at the target. Yes, I understand that, fuckhead. But like a trained sniper, he calibrated the scope to compensate for the wind. Well, he got awful lucky, also, fucker. He even had to take. I wonder how many times if he got 100 bullets. I wonder how many of those would work. He even had to take the curvature of the Earth into account. Of course, luck was, well, at least you admit it, was a huge factor in the kill, but he was able to aim his rifle. Again, I don't need this bullshit. I made at least 10 videos on this subject. We went through all these fine details. Apparently, you couldn't follow along. Alright? So I'm sorry you couldn't follow along, but it's a lot more complex argument than this bullshit. You talk about how you're in a war and you need riflemen. I don't say that, asshole, who can shoot and who can aim, but now I'm wondering if maybe you don't think that's possible. What this is a pointless distraction. Alright? The point was, you can't create a thought experiment even, some sort of experiment, to disprove their theory. And that's kind of the obligation, unfortunately. If you're going to argue against it, you have to come up with some kind of actual evidence to say why what they say happens can't or doesn't happen. Now, I'm not saying they should be allowed to say magical things happen, but apparently that's what physics is now, and they can make up all kinds of stories like Huygens and Heisenberg that they can't prove, okay? But that's all we're stuck with. So you have to play the game we have. You can't play the game you want to play, which is, well, they shouldn't be allowed to make extraordinary claims without any kind of evidence. Too bad, they do it. So the fact that they do it means you're stuck with it. And all you can do is make arguments from logic, how it's probably not the best idea to be invested in theories that you can't defend with evidence. but they don't care. So if you want to go rag on somebody, why don't you rag on them? Why are you wasting my time with this when I've repeatedly stated I don't believe photons can be affected by the thing that's emitting them. The motion of the thing emitting them is irrelevant. They are released in a direction and they move in a straight fucking line. How can I make that any fucking clearer? Shit. I'm deleting this fucking patronizing mush. Always deleting it. Remove it. That's what I said. Remove, please. Are you saying, so this is another comment, are you saying the fighting in a war against mainstream physics? You are saying you are fighting in a war against mainstream physics. Or are you only fighting a war against the pro-lifers? There's a tiny bit of philosophy that ends up mentioned on this channel. I mean, it's a really tiny amount compared to the physics. And I'd like to erase all of it from this channel. And see what you're doing here? You're just emphasizing it now. The very thing I'm de-emphasizing, I even state it when I actually make some kind of philosophizing kind of commentary. I even say in the video, well, that's philosophy, fuck that. And here you are reacting to the very thing I'm saying, don't react to. You see how you're just being a fucking troll? Or are these two groups somehow synonymous? I don't know how you even throw them into the same thing. The point is, in both cases, philosophy and physics, most people are imbeciles. Okay, they believe in, philosophically, they believe in absolute nonsense, religious crap or spirits and spirituality and infinities and magical sources of will and consciousness. They think they have freedom of some kind of weird freedom thing, freedom from learning and freedom from practice. They don't have to practice. They just, I'm free to be talented without even trying. They think they're free. They think all kinds of stupid, idiotic things. So both groups are blighted by a predominance of imbecilic notions founding their understanding. So that's the only comparison I've been using it for, asshole. As though if you win a Nobel Prize somehow that means you've defeated the naturalists. The recognition, the fact that they will have to concede is a kind of victory, asshole. I don't know if you understand, but that's sort of the definition of victory, is when the opposition concedes. And that's what that would represent, is a concession. And if I can win the battle against the dumbest scientists, then maybe I can win the battle against the dumb philosophers. You get it? Too stupid. And of course I'll have a huge advantage if I win against the scientists, because now I'll be famous, asshole. You get it? So I'll have a voice and I'll be able to win the day. I'll be able to fight their kings and their knights. I'll be able to fight a soldier with some kind of stuff. And I'll be able to, knock him off his silly little horse and crack his fucking egg. Anyway. Because I still think my original comment stands. Well, if that's what you still think, I should just block you right now. Because I've only stated it over and over again. Another commenter pointed it out to you, and yet you're still fucking being persistent. Then really, fuck you. You did change your position. Okay, I'll just block it now. I mean, I didn't change my position. I've said it as clearly as I can fucking say it. You're a fucking troll, so goodbye. Alright, how the world works sock. So right there we know we're going nowhere. He's proud to be a sock account, or a troll account, or whatever he's pretending to be. Fuck you, Moshman. Like that's relevant. You are worse than the Nazis. Whatever. You talk shit all day and in a tone that makes me feel
makes me feel want to kick babies in the head. So it doesn't make you want to check your grammar. So maybe I should say something about checking your grammar before you type. Do you have feelings like kicking babies in the head too? Well, if they were your baby, I'd certainly have to say there's got to be a good cause in here somewhere that's worth it. It's probably a baby's head who's worth having a kick. I think you must have, because my mirror neurons mirror your hatred. Well, I don't even believe in mirror neurons anyway. I think it's just silly, more mush scientists have made up. These are silly people. Just like when they made up that whole crap about we're not using, 70% of our brain, because when they stick an electrode in, we don't go butterfly, because we don't label every poke they do in our brain. They say there's nothing there. That's how retarded their science is. Just listen to your fucking voice. You are evil, mate. Well, I guess I don't know what a mate is, so you're some kind of perverse Australian. So you're a toxic waste dump. You are evil because your brain is evil. I don't really believe in evil. So you can say I'm stupid if you want, but I don't think it's a reasonable argument. I don't think you can prove it. You can say I'm delusional. You say lots of things, but evil is just pointless. You don't even try to be good. You don't even try. Yeah, well, your definition of good is what? Torturing and killing animals? I don't know. You insult and bring pain to other individuals with your fucking voice. Well, that's just the price you pay. I would argue that you do the same with your putrid typing. So, does that mean something also? I mean, you want to have a body odor contest, douchebag? Who's got the smellier butthole? I think I'll probably win on the plus side, less smelly. Just shut the fuck up. No, you do that first. You first. And live alone in your fucking hut in peace. Yeah, well, whatever I live in, I don't know how that's relevant. I mean, I could tell you to do something with your micro penis in peace. But don't make fucking videos and put them out there to make it harder on people. So this is on the DraftScience channel, and he's got, he's doing this whining. For what reason, idiot? Do you really think there's some poor little blob of science loonies who are just being tortured? How insane can you people get? Anyway, I'm like Salieri in Amadeus. I've had it. You had it with what? Being mediocre and a failure? I will block you, I swear it. Oh, that's just what a scary threat. I will hinder and harm your creature as far as I am able. Again, I really don't understand that. But do what you have to do, I suppose. I mean, if you really think it's important to stop the new understanding of physics from taking its rightful place, then do what you have to do, crazy person. I will ruin your incarnation. I don't know what that means either. From now on, we are enemies, you and I. Fine, whatever. You're crazy, is what you are. Very crazy. So I'll delete that. So skip win. It's not a winner. Skip dream of winning. Miles, I have a friend that I think you would enjoy meeting. The two of you seem to have a lot in common. Professor Irwin Corey. Perhaps you've heard of him. So I did look up Irwin Corey, and it's like some guy who was supposed to be funny, doing the, look, I'm like Einstein, it's up to, and I just make jokes about intellectuals or something. And it really just isn't funny at all. I mean, incredibly unfunny. So I guess this is some sort of, I think him calling me Miles is part of his joke. Um, I don't really understand. You people are just so pathetic. I mean, it's just so pathetic. So he thought he'd get a rise out of me because he's calling me Miles Mathis, and I'm not Miles Mathis. You know, I don't know. An amazing douche. So yes, that one we can get rid of for good. Okay, so I think that's it for the comments. I guess I'm not desperate to do anything else. I mean, talk about anything else. Always stuff running through the brain, of course. But yeah, I would like to do some. I have to do some playing around with interferometry. Just because I think there's got to be a way of doing it. Like I said, with some other combination, and to try to find a way to do it without the beam splitter, because that has an inherent defect. At least one inherent defect. So anyway, I think that's enough for now. And let's see what else. Yeah, that's enough. So till the next time, and such, and so forth and whatnot. I know there was something else I should have gotten to, but just probably doesn't matter that much. So till the next time. I said till the next